Hello and welcome. My name is Michal, and today we will go through 5 of the latest questions from the AGK, and more specifically, the topic of hydraulics. So, all the questions that you'll see now have been seen in the last 30 days in the actual EASA exams across all authorities. So, let's jump into the questions, let's talk about the answers, and let's dig a little bit more in depth as to why the correct and incorrect answers are as they are. So the question number 1, the function of a hydraulic fuse is to. So the hydraulic fuses are in many places around the aircraft, and their main job is to make sure that if there is a failure or if something detaches or if there is a leak, that the entire system does not depressurize and the entire fluid does not leak out. So think about it in a way that, for example, if during takeoff a gear is ripped off an aircraft, there will be a fuse before the fluid reaches the aircraft, the gear components, and then when the fuse goes off, it shuts down the system before it gets to the system. So, for example, it can be before engines, before some control surfaces, before the flaps actuators. So, if something happens to the system at hand, then essentially nothing will leak out, and this is the main job of the hydraulic fuse. So, of course, going now through the questions, answer number D, so prevent total system loss in the event of hydraulic leak, will be the correct one. So not only the system loss, but also the entire hydraulic fuel, hydraulic fluid capacity is not lost. Because of course, if you lose all the hydraulic fluid, then of course the hydraulic system will not be usable at all. And now for question number 2. So aircraft's hydraulic systems are mainly used for. So a hydraulic system generally and by principle is there to transfer in forces via the use of an uh, incompressible fluid. So this is the general definition of how the hydraulic systems work. And of course, they are there in order to transfer forces from the highly pressurized system onto mainly control surfaces that have to overcome very strong aerodynamic forces in the air. So this means that essentially controlling and actuating large and heavy surfaces will be the correct answer. And here remember also that most of the modern aircraft, although they will be powered with fly-by-wire systems and partially power systems, as it is with the Boeing aircraft and Airbus aircraft, for example, they will still be electrically actuated but hydraulically operated. So these systems all operate using the hydraulics because this is a very powerful way of moving controls and overcoming very high aerodynamic forces in the air. And now for question number 3. A hydraulic low pressure alert is the first indication of. So this question can be slightly tricky because quite a few answers here actually do make a little bit of sense. However, the keyword in this case will be the first. And what the examiners are trying to get out of us in this question is the knowledge that always the systems checks are right after the pump. So the indicators for the fuel, the hydraulic pressure and temperature are always right after the hydraulic pumps, and this means that essentially the first indication that we'll get will be because the pump is giving us insufficient pressure. And of course, also you may ask why not the leak in the reservoir, because of course it will show up as insufficient pressure. However, first this leak will be slightly overcome using the accumulators, and then the pump will try to keep up, and then only then, after all these conditions are met, the leak will be identified. And this will also be the case for the question Charlie. So the hydraulic system accumulator becoming deflated, it will become deflated. However, until it is deflated, we will not really have an indication because the system will stay fully pressurized. And now for question number 4. Which of the following sources of hydraulic pressure is commonly used for operation of cargo doors when the electric hydraulic pumps are not working? So so the cargo doors in the aircraft, of course, they are hydraulically operated. They are very heavy and very big. and they require the pressurization of certain hydraulic systems depending of the aircraft. And for the ease of use, of course, the hydraulic systems are mainly operated and mainly pressurized using the engine-driven pumps. And of course, the cargo doors will mostly be used when the engines are off, of course, for the safety and for the economy of the flights. This means that these doors need to have a way of operating when the aircraft is shut down, and this is done using the electric fuel pump. So we have an electric fuel pump for one of the systems, depending on the aircraft. Of course, for the Airbus, there is a electric fuel pump for the yellow system, and this will allow us to pressurize the system even though the engines are not running. However, the cargo doors will also have a manual way of pressurizing this system, so the personnel can do this relatively on their own without the need of any major systems being turned on or the help of pilots, as it is in this case. And of course, the other answers, engine-driven pumps, no, because the cargo doors are used mainly when the engines are off. The hydraulic accumulator will only be used for dumping and will only be able to re-energize the system slightly in case of any fluctuations. And also the accumulator will allow us to use the brakes a couple times if the hydraulic system is being depressurized. And lastly, the rammer turbine is an emergency way of pressurizing one of the systems, hydraulic systems in an aircraft. It's a small fan that will drop down from the fuselage and will provide the energy to the hydraulic system, which then will be able to provide some electricity in case of a, for example, total engine failure. And so we will, in case we will not have the ability to pressurize the system otherwise. And for question number 5, so the last one for today, which of the following is an advantage of a high pressure hydraulic system over a low pressure hydraulic system? So here for your exams, remember that most of the CAT aircraft will be pressurized, their hydraulic systems will be pressurized to around 3000 psi. So the 3000 will be more or less a benchmark for the modern CAT aircraft. And of course, a high pressure, some aircraft will be pressurized to higher pressures, and the main advantage of these will be, of course, that they can move bigger surfaces, larger surfaces, and overcome more forces because they have more energy inside of them, which is quite straightforward. However, there is another added benefit to this, and it's also said that higher pressure systems like in the A380, for example, which is pressurized to around 5000 psi, which is not the usual 3000, is that it can save some weight as well because we can use less fuel. However, these systems, less hydraulic fluid. However, these systems are much more complicated and they will also put greater stress onto the system, so need to be closely monitored. So there is a trade-off, as it with everything in aviation, that we get something for something in this case. So the advantage of a high pressure hydraulic system will be that, of course, it is able to handle greater loads than low pressure system, and this will be the main idea. However, also remember that in some cases it will save some weight as compared to low pressure systems. And this will be everything for today. So I hope this was helpful. I wish you all the best with your studies. If you have any questions, as always, let us know in the comments. We'll try to help you and answer these. And until I see you again, I wish you a fantastic day. So bye-bye and have a good one.